All right, guys, let's talk about solving these exponential equations. So we got to go back to properties of exponents. Whenever we multiply exponents, we add the exponents, right? They have to have the same base. In order to solve these things, we have to make sure they have the same base as well. They can only have one base. So let's just think for a second. If 2 to the x power is equal to 2 to the 4th power, what's x? Well, it's 4, right? X is 4. That's the idea here. Behind everything we're going to be doing, if we have the same base, then the exponents have to be the same. We don't need the base though, right? I mean, if 2 to the x is equal to 2 to the 4, then x has to equal 4. So whatever our exponents are have to equal each other. That's what we're doing. Let's see. We've got 2 to the x plus 1 equals 2 to the 9. The bases are the same, right? 2 is 2. So that means x plus 1 has to equal 9. Well, that means subtract 1. X is 8. Yeah, really, it's that easy. These are both 5. Okay, so 4n plus 5 equals n minus 7. 1 second. And back. Okay, so we get our n's to one side and our numbers to the other. So 3n is negative 12. Basic linear equation here. N is negative 4. I subtracted 5. Subtracted n. Divided by 3. And that's my answer. Okay, not too terrible. Let's check the next one. Okay, now we got some stuff going on. I have 2 bases over here. We can't have 2 bases. Whenever we multiply with the same base, what do we actually do? We add our exponents. So 3 to the k times 3 to the k plus 2 is actually 3 to the k plus 2. It's k plus 2. Well, I'll just write it out. K plus k plus 2. Let me stop for a second. Make sure you see it. Whenever we're multiplying with the same base, we add our exponents. This k plus this k plus 2. Okay. Equals 3 to the 5k minus 1. Nothing to do over on the right side. I'm going to combine my like terms and I'm going to just drop my base, right? I have one base over here that is 3. I have one base over here that is 3. Okay. So that's going to be 2k plus 2 equals 5k minus 1. That's the basic algebra equation. Just solve the dang thing. 3 equals 3k. K is 1. All right. Here I've got to do multiplication rule. That's going to be 10 to the 5th equals, let's see, v plus 2v. That's 3v's. 4 plus a negative 11. That's negative 7. Okay, so 5 equals 10 and 10, right? 5 equals 3v minus 7. 12 is 3v. 4 is equal to v. Keep going. All right. So right here, I got a 6. Nothing to do over here. That's a 36. That's not the same, is it? What can we do? I need the same base. So can I rewrite something to have the same base? For now, the answer is always going to be yes. Necessarily. 36. That reminds me. What's 6 times 6? Oh yeah, 36. So I can rewrite it as 6 squared. So I can say this is 6 to the 2x minus 10 equals 6 squared. 2x minus 10 equals 2. 2x equals 12. X is 6. Done. So it really helps if you know your math facts here. If you don't, you're going to struggle. I will give you a hint though, don't try and turn something small into something big. It's not going to be happening for you. But you can try and think of powers, like 6 to what power is 36? Let's see, 6 times 6 is 36. That won't always happen because sometimes you might, have like a 4 and an 8. 4 squared 16, 8, no, okay. So you might have to do multiple steps. Use one here, move. 2, I can't change that. I have an 8, I can change that. So somehow I have to write 8 with a 2 as a base. Well, 2 times 2 times 2 is 8, so 2 to the third power. Again, know your math facts, and this will go a lot smoother. So p minus 7 is 3. After you get this part done, it's freaking easy, right? It's just basic linear equations so far. We can throw some quadratics in here. Don't worry, we will. All right. Oh man, I got a regular number, integer, and then I got a fraction. Can't have like fraction and then just an integer. They got to be the same, right? Well, to turn a fraction into an integer, we have to raise it to a -1 power. We've got to reciprocate it. So this is 7 to the 4x plus 11 equals 7 to the -1. If I raise 7 to the -1, that reciprocates. That would be 1/7. So if I raise 1/7 to the -1, that's going to reciprocate it. That's going to be 7. 4x plus 11 equals -1. 4x is -12. X is -3. So after we get this part down, it's real simple stuff. All right, I got a 32 and I got a 2. Hopefully you know 2 to the 5th power is 32. If you don't, use your calculator. 2 to the 3rd power. Oh, 4th power. Oh, not 34th power. That's a little big. 4th power, 16. No. 5th power, 32. There we go. We found it. All right. Now let's set our exponents equal to one another. 14 is equal to 2m. 7 is m. All right. Let's see. 3 and 27. Well, 27 is 3 to the 3rd power. So let me rewrite this. I've got 3 to the 3rd power raised to the 2x plus 6. What the heck's going on here? Equals 3 to 2x. Remember, when we raise an exponent to an exponent, we're going to multiply. So I'm going to take this 3, I'm going to distribute it. That's going to be 3 to the 6x plus 18. It's equal to 3 to the 2x. 6x plus 18 equals 2x. 4x equals -18. X is -9/2. Use a calculator if you need to. Okay, so we're getting to a little bit of tricky area here. So if we have to manipulate these things, just rewrite our base so that they have a common base. It's already got an exponent on it. Whenever we raise an exponent to an exponent, we're just multiplying. Okay, let's try this next one. Okay, I got 4 and I got 16. Well, we could put them as both 2s. This would be 2 squared, and this would be 2 to the 4th. But it's even easier. We know that 16 is 4 squared, right? 16 is 4 to the 2nd power. I'm going to use that because the less work I have to do, the better, in my opinion. So I'm going to leave that 4 on the left side alone. If I let's just write it out. 4 squared to the y minus 3. Distribute that 2. So, in fact, if you want to, you can just write it like this. That's literally what we're doing. We're distributing here. So let's distribute it. One second. One second, please. And we're back. So solve this thing. 8 equals y. Okay. Let's see. Anything really tricky in here? I mean, it just gets more and more and more rules stuck together. Let's see. 125 and 25. I can write both those as 5s. 125 is 5 to the 3rd power, so it's going to be 5 to the 3y. That's going to be 5 to the 2nd power. 3y equals 2. Y equals 2/3. Now, you might be tempted to say, oh, 8 squared is 16, right? No, it's not. 8 times 2 is 16. So we have to write both of these as powers of 2. We can't write 8 as a power of 4. We can't write 16 as a power of 8. We got to go down, down, down. That's 2 to the 4th to 3x equals 2 to the 3rd, 3x plus 2. So I'm just going to write this out with the distributive property here. 4 times 3x, 3 times x plus 2. So if you're comfortable doing that in your head or doing that in another step up here, wherever you want to do it, it's fine. You just have to do it. So you can get some pretty weird answers here. Don't worry about it. This one's going to be 2/9. That is what it is. Don't let fractions scare you. They don't bite, usually. Okay. Can't write a to the power of 4, so both of these guys need to turn into some 2s. So again, if you know your math facts, this will be a lot easier. If you don't know them, it's going to take you a minute. And by a minute, I mean like an hour. So 3x is -3, x is -1. Whew, this guy. So if I look at the 1/3, I can turn that into a 3, right? Can I turn 81 into a 3? Yes, I can. 3 to the 4th power. Did you know that? Hope so. Didn't know that. Figure it out with the calculator. I know it's got to be a base of 3 because it's 1/3 here. Nothing else I can do with that. So you could just do 3 to the 4th power is, oh, look at that, 81. So I'm going to rewrite it. This would be 3 to the -1, right? It's reciprocated. So I'm going to distribute. -20 is equal to -10x. So -2 is x. All right, so here we have to combine into a single base first. If you got multiple bases, you got to put them together first. Can't do anything with multiple bases. Nothing. Now here, I'm going to need a power of 4 or 2. So 64 is 2 to the 6th power. I could do that. Or 4 cubed is 64. So again, the more math facts you know, the better. Like that. So I think it would be easier to do it that way. So I'm going to write 64 is 4 to the 3rd power. What's the exponent here? It's an understood 1, right? So this is going to be 4. Add them together, 4x plus 1. So now this guy's easy. 3 equals 4x plus 1, x is a half. All right, over here, we can do 9. I know 81, that's 9 squared. Okay. So if it's reciprocated, it's 9 squared reciprocated, right? So it's going to be 9 to the negative 2. I reciprocate it, that's going to change it to an integer. And then 81 is 9 squared, so there we go. Over here, though, got to add my exponents together. That's going to be 9 to the 4x plus 4 together. So 4x is negative 6. X is negative 3 halves. Do what you got to do, calculator, whatever. Show it step by step. I don't care. It's a basic linear equation. I'm not going to waste time solving it step by step. Looks like my base over here has got to be a 7. Okay, so I got these things multiplied together. Don't just add the exponents. They have to have the same base in order to add the exponents. See right here, they're both 9s. Right here, they're both 4s. Right. Somewhere. Right here, they're both 3s and 10s. They must be the same base in order to put them together. If they're not the same base, you can't do anything with it. So let me write everything in terms of 7 first. So it's going to be 7 to the negative 1 equals 7 squared to the x minus 5 times 7 to the x minus 9. So I need to go ahead and distribute this before I can do anything else. Now, I've got the same base. I can add my exponents together. Now I've got the same base, and it's only one of them, so the exponents are equal. So that's 18 is 3x, and x is 6. All right. I'll just go ahead. I'm looking at this one. It's probably going to take a second, so I'm going to, or some space, so I'm going to go put it over here. I'm going to break everything. No, I didn't. Okay. All right, so again, we have options. I know I can write 4 as 2 squared, and I can write 16 as 2 to the 4th. But it's easier if I just write 16 as 4 squared. 4 to the 2x times 4 to the negative 2. It's reciprocated, and it's 4 squared. So it's 4 squared reciprocated, that's 4 to the negative 2. All right, that's 4 to the 2x minus 2 equals 4 to the 6x plus 18. Set the exponents equal. And let's see, that's negative 20 equals 4x, so negative 5 is x. All right, so that's done. That's how we solve exponential equations. Okay, so if you notice, they had the same base in order to solve them. That won't always happen. For now, it has to happen, or we can't do it. Next week, when we talk about logarithms, that's when you're going to be able to manipulate these things. They don't have the same base. So we'll get there, but for now, make sure they have the same base in order to solve them. Can't make them have the same base, and either you did something wrong or I made a typo. See you next time.